1.6, 1.7. 1.6 is a problem-solving plan using models. 1.7 is tables and graphs. In this section, we're going to do a little bit differently. We're going to just practice a couple solving problems and a couple tables and graphs, showing you how I do it to give you some ideas for when it's time for you to do your own. So let's look at our first problem here. Number 1, you and your friends went to a music store to buy CDs on sale for $6 each. Together you spent $77.76, which included a tax of $5.76. We're going to use modeling to find how many CDs we bought together. So when I do story problems, I like to think of myself as being there. So I went to this music store and I gave the cashier $77.76. I also know that when I pay somebody at the store, I have to pay for my CDs and for the tax. So if I want to find out just how much I spent on just CDs, I need to take out this tax of $5.76. So that's going to be my first step here. I'm going to take out the tax. To take out the tax, we're simply going to subtract $77.76 minus $5.76. We're going to get $72. So I know that altogether we spent $72 on CDs. So next, how can I find an equation that's going to show me how much I spent and how many CDs I bought? So I know that when I go to a store, if I were going to purchase one of these CDs, I would spend $6. If I was going to buy 2 of these CDs, I would have spent $12. And if I would have bought 3 CDs, I would have spent $18. So I know that the price times the number of CDs is going to equal my total. Okay, I check that using what I know. 6 times 1 is 6. 6 times 2 is 12. And 6 times 3 is 18. So now that I know my problem works, I'm going to plug in what I know from my problem. So what do I know? Well, I know that each one was $6. So my price is 6 times the number of CDs. I don't know. So let's call it X. I could use any letter that I want, but we're going to stick with X here. Equals total. Altogether, I spent $72. Okay, so then we just have to solve this equation. 6 times what equals 72. And I'm going to get X equals 12. Okay. So my problem says that I bought 12 CDs. I want to check this to make sure I was right. So to check, I'm going to plug 12 back into my equation to see what I get. So 6 times 12 equals 72. 72 equals 72, just like we did before. Yes. So my answer is 12 CDs. I'm talking myself through this problem. Imagining myself at the music store, being the cashier. Let's try the next one here. Next one, the Rodriguez family has a vegetable garden that is 8 meters long and 6 meters wide. So I'm going to draw a picture, because I want to be able to see it. 8 by 6. Their neighbors, the Smith family, made a garden with the same area. However, they only had space to make their garden 4 meters wide. So I know for the Smith family one, it's 4 meters wide. I don't know how long it is, they don't tell me. So I'm going to use X again. Okay, so from before we learned our area formula, area equals length times width. I also know that they made a garden with the same area. I'm going to label this for you. This is the Rodriguez one. This is the Smith one. So I know that the Rodriguez area is going to equal the Smith area. Okay? Well, I have my formula for area, and for the Rodriguez family, I have the length and the width. So we're going to go ahead and figure out that area. We're going to take length times width. So 8 times 6, and we get 48. Where'd it go? That's 8, 6. I don't know what just happened there. Let's put this back up here like we had it. Computer had an issue there. So we know that the Rodriguez area is 48. Remember the work we did down here. 8 times 6 is 48. Okay? And I know that's going to equal the Smith area. The problem with the Smith area is that I only have my width. I don't have my length. But let's go ahead and use our area formula that we had before up here. Before it all disappeared. So let's find it. My Smith area is going to be length times width. So x times 4, which is going to be 4x. Remember, we put the number before the letter there. So I know the Smith area is 4x. So now we just need to solve for our variable. So I need to know 4 times what is going to give me 48. And in this case, my answer is going to be 12 meters. Again, meters, because that's what my story problem tells me. So then we're going to check it to make sure we're right. So if that's right, then I should be able to stick 12 in for x and get a true statement. So 48 equals 4 times 12. And I know that 4 times 12 is 48. So in this case, my answer is 12 meters. Okay? Drawing a picture when you can is very helpful. Okay? Just like in the first problem where I imagined myself at the store. Okay? If they give you something that you can draw, drawing a picture is going to help. I think we got at least one more here. Let's see what the next one says. A salesperson drives at a speed of 50 miles per hour. When he is 165 miles from his destination, he remembers that he has a meeting in 3 hours. So question A, at his current speed, will he be on time for the meeting? So here I see a rate, I see a distance, and I see a time. So I know that I'm probably going to use my formula distance equals rate times time, because that's what they're giving me. Okay? So what do I know? I know here that he's driving at a rate of 50 miles per hour. I also know that all he has is 3 hours to get to his destination. So let's use our formula to see how far he can get driving 50 miles an hour for 3 hours. So here's our formula again. So distance equals, my rate is 50, and my time is 3. So when I take 50 times 3, I get 150 miles. Okay, so question A asks, at his current speed, will he be on time for the meeting? Well, from my problem here, I know that in 3 hours, he's going to make it 150 miles. However, I see from my problem that he really has 165 miles left to go. So will he be on time? No. Okay. He will actually be, what, 15 miles short? So if he's 15 miles short, he's never going to be there on time. So the next question asks us, at what minimum speed should he travel from this point on if he wants to be on time for his meeting? So we know for problem B, let's use a different color here, that he still has 3 hours. But this time I want to know what his rate is. Okay. So that he'll make it his distance of 165 miles on time. So let's fill out our formula again. So D equals RT. So this time I know distance is 165. I don't know what the rate is, so let's leave that R, times T, which is still going to be 3. Okay, so let me do the same thing. What times 3 is going to give me 165? Here I find out that R equals 55 miles per hour. So he's going to have to go 55 miles per hour from now on if he'd like to make it on time. Alright, let's see if we can get through one more here real quick before I let you go on. Alright, number 4. Your family and friends are going to an amusement park. Adults pay $25 per ticket. Children pay $15 per ticket. Your group has 13 children, and your total bill is $370. How many adults are in your group? So again, we're going to come up with an equation. We're going to think of ourselves as being there. So if I paid $370, okay, I know I paid for the adults and the children. So I know that the total for my adults and the total for the children, I'm going to add those together because I know I paid for both of them, and that's going to give me my grand total. Okay. So the question is, how much did I pay for the adults? So just like the first problem that we did, I know that the total cost is going to be the price times the number of people. Okay. So let's go ahead and fill that in. The total for adults. Well, I know that the price for the adults is $25. However, I don't know how many people there were. So let's use an X for that. Okay, plus we're going to add the children. Children were $15. And I do know there was 13 of them. And that's going to give me my grand total of 370. So let's simplify it here a little bit. 25x plus 195, that's what I get when I take 15 times 13. Okay. This is a little bit more complicated of a problem. Probably going to take a little bit more guessing and checking to solve for x. However, I know that when I solve this, I get x equals 7. Okay, there were 7 adults. Okay, so again, for all these story problems, if you can draw a picture, drawing a picture would help. Remember our formulas that we've already learned. Distance equals rate times time. Okay, to find a total price, we take the price times the number of things we bought. Think of yourself as being there. Okay, a lot of this you have experience for. You've been to the store and you've bought things. You know how it works. Okay, use your real life problems to do this. Okay, so now at this point, I need you to go and complete checkpoint 1 for 1.6 and 1.7. So you're going to go for 1.6, 1.7, checkpoint 1.